In this film, I will show the basis for how a PLC system is programmed. I will use the programming environment Codesys as an example of that throughout this film. The next film then will be a tutorial on how to start out in Codesys. And in the coming films, I will show more directly how to program different functions in the different programming languages of the PLC system. I will use Codesys as the example of how a PLC system is programmed. So I will start there. But the program structure, but most of the details are more or less the same in different programming environments. But the examples here are as I said, I will use the programming environment Codesys as an example of how to program a PLC system. The main reason for that is that it's free, can be downloaded from Codesys store free of charge, and it's also used by an increasing number of PLC manufacturers today. And it's the only programming environment I can use for the Crevis systems that I have. The program structure is like in most PLC systems. We have an application. The application is my project. I have one application for each PLC that I'm using. And then we have different tasks. For each task, I have several POUs, Program Organization Units, subprograms. The task defines when those POUs should be run and in which order. I can have different tasks within my application. The main reason for having different tasks is that I can say that this will execute as quickly as possible, this will execute only once per second, and this will execute only when a certain signal is true, if I see the need for that. In the examples that I will show, I will only have one task. The different POUs can be written in different languages. We have 5 different languages in the IEC standard. But I can only use one language in each POU. So if I, for instance, want to use ladder and function block diagrams, I will need to have one ladder program and one function block diagram program. And they can communicate and will be run in the order that the task shows. We can see this in the Codesys device tree as well. Here is my application, and now here is my main task, and I also have a second task, task 2 here. In my main task, I will run my FBD POU and my LD POU. In my second task, I will also run the LD POU and the SFC POU. And here is the structure as described in the previous slide. As in all computer systems, we need to have some kind of definition of what we are communicating. Hence, we need to declare the data types of our variables. I have some of the data types used in the PLC system here. We have bool, already shown that for the inputs and outputs. They need 1 bit, on or off. They can be true or false. Not 1 and 0, true or false. And if we don't define the starting value of the Boolean signal, it will start as false. Then we have integers, positive and negative numbers without any decimals. Those are 16 bits, here is the range. If we want to have higher numbers than that, we can use a double integer, then we have 32 bits. If we need only positive numbers, as in the analog input and output modules, we can use word, 16 bits, or double word, 32 bits. The PLC system has a data type for time, it's called time. It uses 32 bits, and we can write it like this: T hashtag, and then the number of days, hours, minutes, seconds, and also milliseconds. Don't need to have all of them. You can have just T hashtag 5S for 5 seconds, for example. But this is the range, almost 25 days. And as everything else, it will start at 0 if it's not declared where it should start. We also have the possibility to use decimals, which in many languages is called float, but here they are called real, for real numbers. You need 32 bits, and the range is 10 to the power of minus 38 to 10 to the power of plus 38. Now we know the data types for our variables. Not only do our variables need to have a defined data type, they also need names. Names in our PLC system are called identifiers. Variables need names, but also programs, functions, function blocks, everything that uses memory in the system need a name, an identifier. Names or identifiers in the PLC system are not case sensitive, which means that, for example, the variable name Apple with all caps will be exactly the same as the name Apple with lowercase letters, or Apple in a mix of caps and lowercase letters. I can use letters, numbers, and underscore for the names, and only that. And the identifier cannot start with a number. It must start with an underscore or a letter. And I can never have more than one underscore at a time. Now our variables have both the data type and the name. As in most programming languages, we can use variables as local and global. A local variable is only accessible within the POU where it's defined. A global variable is accessible for all POUs within the application. In some PLC systems, the physical inputs and outputs need to be global variables, and I will also use them like that in those films, even though Codesys allows me to have local variables as physical inputs and outputs as well. The global variables can also be used for communication between POUs, but I can also define inputs and outputs for my local variables within my POUs, and they can be used for communication between the POUs as well. When I showed the list of data types, I said that all variables will be initialized to 0 or false if it's a Boolean, if we don't say anything else. Sometimes, or quite often, we want to initialize the variables to something else to have the system to start up at the correct values. And that is done in the variable list. Here I have an example of a local variable list. I will show both the local and the global variable list in the next film where I show how to use Codesys. The variable lists can be shown both as a table and in text, where I declare the name, the identifier, the data type, and the initialization. In text, I have the name, colon, the data type, and then the initialization as colon equal, and then the number. In the next film, I will show how to start in Codesys, and in the coming films, I will show in more detail how to make programs in the different programming languages for the PLC system with examples in Codesys.